Creating a definition file, in other words, a function file, is pretty similar to creating a regular script. The commands that you've learned in the past will still be applicable. If, while, everything. There's just a different presentation at the very beginning of the file. So we'll create a definition file, we'll understand arguments versus parameters, and how the variables go in and out of the function. In order to write a function, like I said, it'll be very similar to before. So open a new script file. Then we still have to figure out a name. Now when we used to name files before, we didn't really care about how it was going to go. We had rules to follow, meaning it couldn't start with a letter, couldn't have special characters except the underscore. We did not want to use an existing keyword, and we needed to keep it less than 63 characters, which was really easy. However, when we named a variable, we absolutely did not want to name it the name of our file. For function, it's the actual opposite. The name of the file has to be the name of your function. Little caution here. We do not refer to this as the function call. Some students in the past have mixed the two. There's a huge difference when in class we ask you what's the function call versus what's the function's name, or, I do agree it sounds similar, what's the function called. There's a huge difference between the two. As far as inputs, the inputs are what we call the argument. Remember, the ceil, the floor, the square root all needed arguments to work with. There can be 0 arguments, such as CLC and clear. They do not require input. But it's also unlimited. Look at the fprintf function. As far as the return values, we have the same idea. There can be 0 return value, again CLC and clear are examples, or they can be unlimited amounts. The most we've seen so far is 3 with the xlsread function. Now when we write a function definition, you have to think of it as being magic. There is code behind that function and it will execute. Sometimes we don't care how it does it, it just does it. What goes into the functions are the inputs, in other words, the arguments. There can be of any form. We can hard code them or we can place it in variables. They can be of any shapes. This means any kind of arrays or even a scalar. And they can be of any data type. Char, double, string, logical, anything can go in a function. What comes out is pretty similar, except it will never ever be hard-coded. Obviously it's going to change. Every time you call the function you want a different result. So it's never going to be hard-coded. But again, it can be any shape and any data type. When we create a function file, this is what it will look like. The function's name has to be the name of the file. But the first keyword that we will type is the actual word function. This will tell MATLAB that this file is going to be a keyword. The return variables are placed immediately after, in brackets. Then we have the equal sign, the actual function's name, and then in parentheses what we call the parameter list. Underneath, we have a quick description of what the file is about and how it works. Then we finally reach the author and the version. Notice how our name and our section and everything that we used to put at the beginning of a file is no longer at the beginning. Function is really the first keyword MATLAB needs to see. At the very bottom, though, we call it the function's body. It's exactly previous code. If statement, while loop, anything that the function needs to do. If there are more than one argument or return value, then we separate each variable by a comma. What's the difference between argument and parameter? As you've noticed, I have not put inside the parentheses argument list. So what's the difference? Officially, parameters are the variables within the function definition. So within that particular file, we call it parameters. MATLAB will use this information to process. but the arguments are the actual values given. Very simply explained, think about the word parameter. We have a lot of devices out there that use parameters. This little emergency radio has parameters. The channel, the tuning, the volume. We need to set those parameters to actual values for the actual radio to work. Here's another one. Aeromodelism. A lot of parameters can be changed on this one. Think even about your cell phone. How many of you have gone into your cell phone to change the parameters? Either the ringtone, the volume. Those are all ideas that one day will have a value, but we can change them as much as we want. The argument on the other side is the actual value we use. So the volume is set to a specific volume of 5 maybe. 5 is the argument. There's a very tiny difference between the two. Parameters are the big pictures. We don't really have values for them yet, but we know they're going to be changing. Argument is the actual value that we set it at. You'll notice that whether it's a built-in function or a programmer-defined function, there will be no difference as far as visual. Here's the sind function in MATLAB. Notice the first keyword on the first line is function. Then we have one return value, an equal sign, the function's name sind, which is the name of the file. Those two have to match. And then in parentheses, we have the actual parameter, one parameter. Again, function is really the first word of the file. Your section number, your title, your author, anything that's particular to you is way, way, way below. All the documentation and how the function works is the first thing after the first line. This is only going to use single % sign. If you ever remember asking for help in MATLAB by typing help followed by the function's name, this is exactly what shows up. So when we write our own functions, we need to do a similar idea, in case somebody else wants to use our function. There are 3 basic rules to make a function work. The function file and the main script file should be in the same directory at this point. All the parameters should be used within the function body. If one is not used, MATLAB will underline it in orange and tell you, why are you giving me an input if I'm not going to use it? For example here, there's 3 parameters, A, B, and dim. Those are absolutely used within the function. At the bottom here, you can notice that A and B are used. Dim has to be somewhere down there. Last but not least, all the return variables must be assigned a value. So within the function body, you have to give a value to those variables. Otherwise, how will MATLAB be able to communicate those results back? Same thing. If we don't use them by mistake, MATLAB will underline it in orange. And better, MATLAB will actually crash during runtime. Here's the sign function. If you notice, there is one return value, which is x. And if you look at the bottom on line 20, x is assigned a value. Whatever is on the right side will actually be returned when the function is done. So those are basically the 3 rules that we have to do. Let's do an example. Create a function that helps a company price a pizza. When the operator receives your call, it needs to know a couple parameters. Maybe the crust type, ingredient number 1 and 2, and then would you like delivery or not. The function should return the price of the pizza as well as a fee for delivery. It should return those 2 values separately. These right here are the parameters that we have to use in our function. Notice that when you write a function, you're kind of writing blindly. You don't know any of the values. What type of crust? You don't know it. What ingredient one? You don't know it. But in order to code, you're going to simply use the variables. So this is where you end up. Well, how do you create a function file? The first thing you do is you create a new script. The first word that you type is function. Not your name, not your section. That will go way down here. After the keyword function are the return values. What does this function need to return? Well, we were told the price and the delivery fee. Since there are two return values, notice the comma and the brackets. The name of the function, I chose it to be pizza price, and then within the parentheses, these are our parameters. So we'll have a crust, we'll have ingredient 1, ingredient 2, and delivery yes or no. Again, I do not know the values of these variables, but I have to work with something. Notice how everything is orange. I have not used a single one of my parameters, so MATLAB is telling me, why bother giving me values if you're not using them in your code? And same thing for the return values. These must be set to a value. Otherwise, how MATLAB is going to return a value is unknown. But we're just starting. When you hit the save button, already MATLAB gives you the name. This is something different than before. Just by putting the keyword function at the top of your file tells MATLAB this file is very, very specific. The name of the file needs to be the name of the function. Don't change it, otherwise nothing will work. I'll put it on my desktop in the new folder. There is no reason to run an actual function except to change the directory. If I run a function right now, I don't even have a crust, I don't have any ingredients, I don't have anything. But the huge advantage, it will change my directory. Change folder. Do not do add to path, but change the folder. So there you go. Now I can work with my function. We'll go back to the documentation a little bit later. So, well, we have to print ticket. We'll do a price between $10 and $25, and we'll handle the delivery fee. As far as printing the ticket, you ordered. Generate a price. Notice how I am using the actual word, variable name, very specific to appear. This variable needs a value by the time I'm done with my function. So this is why I use that specific word. Immediately, this is no longer orange. MATLAB recognizes that I used the variable price and I gave it a value. This is the equal sign. So MATLAB is okay with that one. I've used crust, ingredient 1 and 2 in my fprintf, so MATLAB is no longer orange up here. However, I still don't have deliverable yes or no used, and I don't have a fee to give back. Let's do a $5 fee. So now I am using absolutely all inputs, so all parameters are used, and then I am also returning every single value. Price will have a value, delivery fee, whether I use it or not, yes or no, has a value to give back. So everything is set and ready. The last thing we didn't do is the actual documentation at the top. Imagine you want to use the input DLG function. There's 3 ways to actually look at it. You can ask MATLAB help using the documentation. That actually opens the documentation, shows you the syntax. You could have also done help input DLG. It basically shows you the documentation inside the command window. But if you actually look at the file itself, it is a function. And look how much documentation there is. There's about 47 lines of documentation. This is exactly what showed up when we did the help. Input DLG answer creates a modal dialog box that returns user. So this is why we do a documentation. Most of us have never used a lot of functions, and the first time that we try to use it, we look at the help files. So when we write our own functions, we need to do the same. First thing is usually the actual name of the function. Now MATLAB has a habit of doing capital letters. Why not? The second thing is how to use it. This is a simple copy-paste. That tells the programmer, you and me, the order of the parameters and the order of the return values. If you just tell the programmer there's 4 values to give in, there's a lot of combination you could do. But no, the first parameter is crust. The second and third are the ingredients, and the last one is delivery. This makes a huge difference when you call the function. When you do the fprintf command, the first thing is the string, and the second thing is the actual variable. If you try to flip it around, it won't work. The order of the arguments at this point you're trying to call the function is very critical. So by showing the actual function definition, the one line, the programmer knows how to call the function. After that, you can write as much as you want, but use the $sign. Here, crust, ingredient 1, ingredient 2 are strings. For example, pepperoni. Del Y no is a single letter, yes or no. If it was multiple letters, we would have to change our entire code down here. So this is how you tell very specific details about the function. When you're done, just skip a line and leave your name and section. Save. Now you officially have a function called pizza price that you can use just like you use fprintf, sine d, cosine d, and so on. Imagine you want to order a pizza. With thin crust, pepperoni, cheese, and yes, delivery. These are the arguments. You're actually giving real values to those fancy variable words that we had to use in our function. So I ordered thin crust with pepperoni and cheese. The price was $22.22. And then B is the delivery fee. Notice how I didn't name these specifically yet. The variable inside the function are completely independent from your command window, from any other script files. So I name them exactly the way I want to. This is just the command window, so I'm testing to see if the function works. If I write an actual script file, a real script this time, well, I might want to give them better names. But A will be the price, B will be the delivery fee. I can test it again with the no delivery. Now my price is $23 and my fee is $0. Here's a good visualization on how to think about variables inside a function. What happens in Vegas stays in Vegas, meaning whatever variables are inside will never ever make it out of the function. They are completely destroyed after the function ends. There's possibly identical variables used in and out of the function, but there are different places in memory. Only the values are returned. Think about sin d and square root. What are the chances that the actual function uses a variable called x? Very high. It's math. So to calculate the square root, MATLAB in its memory, in its function file, probably uses square root of x, and then processes the information with the parameter x. On our side, we used x to collect the result. That's a huge difference, but there's two variables x that are completely independent in memory, and MATLAB handles it. Being able to write a function file is the main point of this tutorial. How to set it up takes practice. Recognize the difference between the variable inside and the variable outside of the function. Write a function call to test the function. I use the command window. And write a new script that uses the function. Each function is a new .m file. The file name matches the function's name, and thankfully MATLAB actually names it for us. The first word, the very first word, is function. The documentation is the text that shows up when other programmers want to use the function, and the code must use the parameter variables and must assign a value to the returned variables.